Welcome to your severe weather analysis for Brisbane, Wednesday, December 10th, 2025. This morning's sounding was taken at 10 a.m. local time. We are seeing a very stable atmospheric environment with minimal convective potential. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we have a remarkably stable atmosphere over Brisbane. The red temperature line and green dewpoint line show the environmental profiles, with a dashed parcel path showing where air would rise if lifted. We are seeing only 142 joules per kilogram of mixed layer CAPE, which is well below the threshold for organized convection. The surface temperature is 27.1 degrees with a dew point of 19.5 degrees, giving us a 7.6 degree spread. There's a shallow inversion layer just above the surface between 862 and 838 hectopascals, acting as a weak lid. The lifting condensation level sits at 964 meters above ground, which is relatively low and would normally favor convective development, but we simply don't have the energy available. Wind shear through the lowest 6 kilometers is only 10.1 meters per second, which is marginal for storm organization. The significant tornado parameter is near zero at 0.03, and the supercell composite parameter is similarly weak at 0.13. This is a classic sub-convective environment where even if parcels were lifted, they wouldn't have enough energy to sustain storms. Now let's look at the afternoon forecast with solar heating. The enhanced plot shows the blue shaded area of convective inhibition and the pink shaded area showing CAPE. When we heat the surface parcel to the forecast maximum of 29 degrees Celsius, we see an interesting transformation. The heated parcel, shown by the orange dashed line, rises through the morning environment which remains unchanged. However, the afternoon mixed layer CAPE actually drops to essentially zero, less than 1 joule per kilogram. This counterintuitive result occurs because the heating increases the temperature dew point spread at the surface, making the parcel more buoyant initially but reducing its overall convective potential. The surface-based CAPE remains at 545 joules per kilogram, which is marginal at best. The Australian Severe Weather Potential Index increases slightly from low to marginal, with a score of 15.8, but this is still well below the threshold for organized thunderstorm activity. Allen's discriminant, which combines CAPE and shear, calculates to 25,936, well below the 18,000 threshold for likely thunderstorms. Bottom line, even with afternoon heating, conditions remain unfavorable for convective development. Looking ahead to tomorrow morning, the machine learning forecast shows conditions remaining subconvective with 0 joules per kilogram of CAPE and surface-based CAPE also at zero. Wind shear increases slightly to 11.7 meters per second through 6 kilometers, but without any convective energy, this shear won't contribute to storm development. The lifting condensation level sits at 1147 meters above ground. All severe weather indices remain at zero, indicating no tornado, hail, or wind threat. Tomorrow afternoon's forecast continues the stable pattern with 0 CAPE and 0 surface-based CAPE. Shear increases to 13.7 meters per second, but again, without convective fuel this is irrelevant for storm potential. The supercell composite parameter, significant tornado parameter, and significant hail parameter all remain at zero. The lapse rate from 700 to 500 hectopascals is 5.9 degrees Celsius per kilometer, which would normally support convection, but the lack of low-level instability prevents any development. Expect another quiet day with subconvective conditions. The hodograph shows the wind profile through the lowest 12 kilometers of the atmosphere. The colored wind vectors curve from southwest at the surface to west-northwest aloft, indicating modest directional shear. The 0 to 6 kilometer bulk shear magnitude is 10.1 meters per second, which is marginal for supercell development. Storm relative helicity in the lowest 1 kilometer is 63 meters squared per second squared, and in the lowest 3 kilometers it's 201 meters squared per second squared. These are both below the thresholds typically associated with rotating updrafts. The bunker's right mover vector, shown by the red star, points toward the east-northeast, meaning if supercells were to develop, they would track toward the east-northeast. However, given the lack of CAPE, supercell development is not expected. The left mover vector points toward the north-northeast. The wind profile shows modest veering with height, which would support storm relative inflow if we had sufficient instability, but in this case it's a moot point. The atmospheric refractivity profile, or N profile, shows the vertical structure of atmospheric stability. The blue line represents the Brunt-Väisälä frequency, which measures atmospheric buoyancy. Strong oscillations in the profile indicate layers where parcels would experience restoring forces. We can see elevated duct conditions highlighted in orange between about 1,000 and 1,300 meters, which can trap radio waves and is a signature of temperature inversions. The yellow band shows superrefraction zones between 2,000 and 2,700 meters, where radio signals can propagate beyond line of sight. From a severe weather perspective, the N profile confirms what we saw on the skew-t. There are stable layers in the lower atmosphere that would resist vertical motion. The profile is relatively smooth through the mid-levels, which would normally allow for sustained updrafts if we had sufficient CAPE, but the low-level stability is the limiting factor today. To summarize, Brisbane is experiencing a very stable atmospheric pattern with minimal convective potential. Morning mixed layer CAPE of 142 joules per kilogram drops to near zero this afternoon despite solar heating. Wind shear is marginal and severe weather indices are all well below action thresholds. Expect quiet weather today and tomorrow with sub-convective conditions. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is for educational purposes and should not be used as the sole basis for safety decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.